1. Lewis.arrow structure is where you have to make 1 the element octet, meaning having 8 electrons. So the first element will give the amount of element is based on the row above the element. If the second element already has 8 electrons and the first element still has electrons to give, then you will create another second element so that the first element can give to the second. You also create more the first if it doesn't have enough to give to the second. Then you put how many of that element and charge for the first and the second. You put the amount with brackets inside is the second element dot structure, and out the bracket is the charge for that element. 2. Draw-Born-Haber cycle is where you deconstruct the chemical formula into the charges of the reaction. Though you have to create products for the compound for the question and balance it to equals the amount of the compound. You'll have arrow to the reaction above, that is triangle FH of that product. Then you up arrow to the states, which will always be AG on those arrows. The one for the first element will be the triangle H atom, while the other arrow will be the amount timing the second element will times triangle FH that element. Then you go up arrow the element till it's to the charge of that element, but usually the second element will always contain 1 negative charge. So what's on the up arrow for the second element is the amount in the second element times triangle EAH. As for the first element arrow going up to the element charge, the first arrow will have IE1 and going up the amount till the charge for the element is complete. When you're done with both charges, add a and sign in the middle, then draw an arrow from the second charge to the final product below. On this arrow it will have triangle H lattice. Part B. Calculate lattice energy. You be given most of the information but need the formula to solve it. So triangle H lattice equals triangle FH of reaction in the question minus parenthesis triangle H atom plus IE1 plus IE2 plus IE3 if there is one. If not, end parenthesis at IE2, then minus parenthesis amount in second element times triangle FH plus amount in second times triangle EHH parenthesis. The ANS will be in kJ over mol. 3. Increasing lattice energy. This one, all the compound will have the same second element, so whatever is closer to that element has more energy. Then whatever is farthest has less energy. Then the lowest boiling point will have least energy. The lowest solubility will have the most energy. You'll have the least to greater sign when doing the order to increasing energy. 4. You'll be given molecules and need to draw Lewis structure, give electron group geometry, molecular geometry, and hybridization. When you draw the Lewis structure, you put the total amount of electron or dots in the compound. If the element has a plus or minus in it, then you have to put the plus on the Lewis structure, then put that inside brackets, outside the brackets put the charge. Also you take away the amount that in the charge from the compound. If the electron group, if the Lewis structure has 4 elements around 1 making a plus, then it a trigonal bipyramidal if the compound has a plus charge, or it's octahedral if it has a negative charge. If electron group for the Lewis structure has 3 elements around 1 element, then it's trigonal planar. For molecular geometry, for trigonal bipyramidal, if it has a plus charge, then it's seesaw. As for octahedral, if it's a negative charge, then it's square planar, and if they're not charged, then it will be the same as the electron group. As for hybridization, sp3d will be in for trigonal bipyramidal. SP2 for trigonal planar and SP3D2 is for octahedral. The list for electron geometry is if there is two bonds it's linear and the hybridization is sp. 3 bonds it's trigonal planar and if there is one lone electron then it's bent 120 and hybridization is sp2. For 4 bond it's called tetrahedral and its hybridization is sp3. But if one lone electron it's called trigonal pyramidal and if two lone pairs is called bent 109.5 degrees. 5 bonds is called trigonal bipyramidal and the hybridization is sp3d, but if it has one lone pair it's called seesaw, 2 lone pair is T-shape and 3 lone pairs is called linear. Lastly, if it has 6 bonds it's called octahedral. If there is one lone pair it's called square pyramidal, if 2 lone pair it's called square planar and the hybridization is sp3d2. 5. Bond polarity is solved by you are given compound and you are supposed to draw arrows to the element that has a greater charge. If there is an arrow direction then there is a dipole and if there not there's no dipole. To decide the electronegativity of compound you minus the 2 element amount of electronegativity. When you minus the 2 and it equals 0.0 to 0.3 it's non-polar covalent. If it equals 0.3 to 1.7 it's polar covalent. And if it equals 1.7 to 4.0 it's ionic. 6. When you need to draw resonance structure you put the double bond in different placements and put the charge in the Lewis structure. Draw double-ended arrows after finishing one structure and before drawing the next structure. To draw a resonance hybrid structure you will have all bond on that element, but the bond lines will be dashed. Also the charge will change. On top you have the amount of bond minus 1 over the total amount of bonds and it should always be a negative charge. 7. Enthalpy charge is solved is by you are given a chemical formula and have to draw out the Lewis structure for each compound. You'll need to use this formula. Triangle RH equals a sideways M inside is triangle H bond formed. So equals amount in the first compound bond time the charge for the element plus amount in the second compound bond times charge in the second compound bond minus amount in first reaction compound times charge for that compound plus amount of bond in second reaction compound times charge plus if there another bond in the second reaction then put the amount in that compound times the charge for the compound. The ANS will be in kJ/mol. 8. Drawing a valence orbital you use SPDF and fill the line dash for each compound till you reach the element you have for that element. Use the last 2 electron config letter in that element only when filling up arrow first then down arrow on the line dash for each letter in the electron config. When doing a valence hybrid you will put LP for the arrows that has pair meaning an up arrow and down arrow in that line space and sigma for the lone pair meaning it only has an up arrow. Then put the hybridization for that element based on the bonds it would have. 9. Molar orbital is where you have a big hexagon on left and right of it. It has 2 pm. On top it has sigma root star 2p and bottom has pi 2p and inside this big hexagon is a smaller hexagon. The smaller hexagon top had pi root star 2p and bottom has sigma 2pm. Below that it has a small hexagon on the left and right it has 2s and the top it has sigma root star 2s and the bottom has sigma 2s. You'll place up arrow and down arrows like in an electron config line. You will fill out the small hexagon first, putting all the arrow on the left, right and then the top and bottom. Then you fill the big hexagon next and then the small hexagon. Add or minus arrow if it has a charge. Remember, if and charge take away arrow and minus charge adds arrow. B. Solve for bond order. You have the amount of bond in that element minus number of electrons, divide by 2. So count the pair electron you count in order from sigma s, pi p, and sigma p. Then for electrons is order of sigma root star s, and pi root star p, and sigma root p. C. State of mole is if all charges are paired, meaning all have up arrows and down arrows. It's diamagnetic and paramagnetic if they're an up arrow alone.